Okay. Thank you, folks, for joining us here today. Hope you folks have been having a great build and have had a chance to go attend a bunch of different sessions and get a hold of all of the announcements that have been going on and have had good conversations. So thank you for choosing this attend this session specifically at this time. I understand it's starting to get sunny outside, which is a rarity for folks who aren't here in Seattle. So thank you for choosing this over the sun. Today we're going to talk about how you can secure next generation AI applications with Azure Container Apps serverless GPUs. We have an amazing lineup of speakers here today who are going to share some announcements that we have to make, walk you through demos, show you how you can leverage serverless GPUs in your setup, and also provide some deep dives into the technology. So I'm Vyom Nagrani. I'm the product management lead for Azure Container Apps. I'm joined here by more folks from the Azure Container Apps team. Carrie and Anthony who are experts in this area and who can go way much deeper and kind of show you exactly how things work. And we have built this capability of serverless GPUs in partnership with NVIDIA. And we are very thankful to have Alex from the NVIDIA team joining us to also walk through some of the deep integrations that we have been working on with his team. So today's agenda, we'll try to highlight kind of three different topics around how you can do inferencing with Azure Container Apps and serverless GPUs. So this kind of shows you a highlight of how these technologies are, how you can enhance performance and scalability, and how you can use these to build AI applications. Next, we'll delve into specifically into NVIDIA NIMs and Apache Spark, and exploring how that integration with serverless GPUs can help you optimize some of the data processing workloads and analytics capabilities which you would want to build. And finally, then we'll be talking about the importance of securing AI-generated code, particularly through dynamic sessions on Azure Container Apps, ensuring that all the innovations that you're building are effective and secure. And each topic is kind of designed to give you an insight into what the cutting-edge technologies are that the team here is working on, and how it can help you generate improved outcomes. So let's jump into the first topic. But before we kind of go there, I just want to get three quick questions, if you folks may. How many of you folks are already familiar with Azure Container Apps and have started building things with Azure Container Apps? Okay. The second question, how many of you have been exploring how you can use different models, whether it's language models or it's any other type of models, and you're kind of already playing around with different models there? Okay, something which is not coming just out of the box, something more than what the default is. Okay, interesting. And how many folks already are trying to go into fine-tuning or even to the extent of building your own custom models? Okay, that's very interesting. Hopefully you can find some of these topics interesting here then. So then let me give a little bit of background context of why what I was describing is important. So generative AI has been a rage for the recent years. Everybody's been talking about it. We are seeing lots of things going on in this space. But high level, I think we've been seeing a couple of 4 different trends which I'd like to highlight, which specifically enterprises are looking when deploying these generative AI applications. So first is with multi-model. What I called out, most of the organizations that we've been talking to, 93% of organizations are experimenting with more than one model. So it's not just always the default model which comes out of the box. Hey, look, we'd like to play around and figure out what's the best model for the scenario. Agentic AI is a new wave. We've been hearing quite a lot about that in the past few days, but also in the past few months as well. 50% of the companies who use generative AI will be looking at launching agentic AI pilots in the next 2 years, is what we are seeing, which kind of bringing in a lot of task automation across multiple AI agents. But then there's 2 challenges to this. One is trust. Now about 60% of the people are wary about trusting these AI systems, because that goes from a very deterministic model where you know exactly what the output is to a stochastic model where you approximately know what's going to come, but you're also trying to figure out how do I make this safe and secure for my end users. The other one is that data residency is a critical requirement when it comes to trust and security. Like, how do we deploy these, which can be applied across multiple customers, across multiple industries, especially for things which have special requirements, like healthcare or finance industries. And the last one there is that we have production tooling challenges. Like, once we figure out, like, going to POC is one thing, but how do you go from there to production, where 30% or fewer, so less than a third of companies have actually figured out the right set of tools which they're going to need to go from their generative AI experimentations to move to production. So at Microsoft, you'll see that we are offering a complete suite of AI applications as well as AI tools, which will kind of help you throughout that journey to build AI-powered different scenarios there. And over the past 3 years, GPU has become a big thing in how these models are going to be executed. Now, developers can access various AI models through different surfaces which we have. Foundry is now becoming the forefront of that. But we've had different surface models across these, from GitHub Copilot to getting foundational models in there, to Microsoft's own models, to open source models, to partnerships which we are doing with Hugging Face and NVIDIA. But then setting up the AI infrastructure becomes the next challenge. Is how do you go from, I have the model, but then how do I go to setting up my entire infrastructure, my GPU VMs? How do I get the right drivers? How do I get the models to be loaded in the right place? Now, managed compute has come a long way from where it was 3 years ago, but that still remains one of the top challenges that we are hearing from customers. And then developers face limitations in choosing the right model. Like, how do I know which is the right model for me? How do I go and play around with a bunch of these models? Cold start time starts becoming a question. Well, if I'm going to play around and I want a infrastructure that can go and see 20 different models in place, the infrastructure costs start becoming a big concern. And as the number of models grow, like, it's going to be even more likely that folks are going to want to try out many more models before kind of figuring out what the right one is for you. So that's probably where some of these things that we are building can help. So as we are seeing that you can have a model of your choice, the flexibility to bring the model of your choice into your AI application is going to be the critical factor which we are trying to solve here. And that getting that tooling in place where you can have the intelligence tailored to your specific use case so that you're not always going to this one model hoping that it'll do everything for you. So the challenges which we talked about there, right? Data residency, the AI infrastructure management, and efficient cost management, those are the challenges which we've been trying to solve with the serverless GPUs. So Azure Container Apps overall, it's a serverless container platform which can help you build and deploy cloud-native applications. And it abstracts a lot of the complexities of container orchestration. It abstracts a lot of the things which you typically have to do when it comes to infrastructure management and provides you a good abstracted platform, which is simplified. It gives you serverless capabilities, so it can instantly scale out really fast. It can scale back down to 0, so you don't have to pay for things when they are not in use, giving it an easy tool for you to play around with different things. Hey, if I want to try different things, 20 different things, go launch 20 things. You're only going to pay for the one which is actually running. And you typically don't need a steep learning curve there to first learn about how containerization works and Dockerfile works and Kubernetes and infrastructure. All of these are abstracted into simplified APIs backed by Azure, which you can directly use to deploy your applications. And while it provides it's a PaaS solution, it still is built on the same set of CNCF and open source projects, which allows you to kind of also leverage that open source ecosystem. So it's the same Envoy and the same CADA and the same Kubernetes behind the scenes which is being used. But it allows you to build these event-driven, serverless, containerized applications at web scale. So what we have done then is married both of these concepts together, where on one hand, you want AI infrastructure, which is GPUs, and you want the next generation, you want the right set of GPU frameworks and the tooling to get the models in, with the benefits of serverless, where you get these scale to 0, rapid scale out, where you can go from 0 to 100 copies in like a matter of minutes, and you don't have to manage an infrastructure. So to walk you through that, I'd like to call Carrie on stage. We can kind of give you a quick overview of what Container Apps is and where it fits in.
Awesome. Thank you, Vyom, for that great overview of current AI space and the introduction to Azure Container Apps. So up here, we have some of the different platforms that we can deploy to in Azure Container Apps, jobs, dynamic sessions, and now serverless GPUs. So Vyom has touched on this a little bit, but I love Azure Container Apps. I'm a little bit biased. But that means that I love serverless GPUs. And the reason for that is that you get all the benefits that you inherently get out of the box with Azure Container Apps, but now for GPU workloads. All right, so Vyom mentioned the automatic scaling, scale to zero, pay-as-you-go pricing. When you're done with your training workloads or your inferencing workloads, you'll automatically scale back into zero. You're not paying for anything that you're not using, which is really nice for GPUs because they're expensive. Also, at its core, Azure Container Apps is a developer-first container platform. What that means is that we focus on abstracting away the infrastructure pieces so you can focus in on the core AI application code that you care about, right? So you don't have to worry about OS drivers. You don't have to worry about CUDA. We'll integrate and deploy all those to your container apps for you so you can just really focus in on the core application code that matters to you. And with that comes a lot of flexibility, right? You can bring any of your Linux-based containers and run them on Azure Container Apps. Whether that be the latest Hugging Face model or DeepSeek R1 when it launched back in February, or even NVIDIA NIMS. You can take any of these models from all of these different places and run them day zero on Azure Container Apps as a container. There's no waiting for additional products to provide support. And that gets us to one of our biggest announcements this week. So this week, we announced public preview for Foundry models on serverless GPUs. This is in the theme of integrating with all of these different options for deploying your models to serverless GPUs. And we're basically making a turnkey option for you to be able to deploy Foundry models to ACA with just one command. With that, all the models that you're deploying from Foundry, they will be deploying straight to your container app environment. This means that there's no endpoints external to your environment. The models themselves are running within container apps in your environment. You can integrate it with your own networking, your own security. You have full control. Now, with that, I think we've had enough slides. I'm going to get behind the desk here, and we're going to go over a demo. So the demo that I'm going to be sharing with you guys today is a multimodal expense report agent building with Ollama and Foundry models. So here you can see we have our Azure Container Apps environment. And within this environment, we have 5 different applications. So we have a front end, pretty self-explanatory, right? Customers can come in, they can upload their PDFs, their documents, and then they can also see their reports and whatever documents they've uploaded. There's an API gateway acting as a middle layer, talking between all these different services and handling the API endpoints. And then we also have a document service, right? This is sort of our core bread and butter for our company, right? This is what is proprietary to us and what's going to be leveraging the models to do the actual expense report generation. And finally, we have a Ollama model application, as well as what we're calling a Foundry model application here, right? So these are 2 different places that you can deploy models from, and these are running, again, within the context of your Azure Container App environment, so that the data is never leaving that environment, and they're able to communicate easily with those other applications. So with that, let's jump over. So here, we're in our code, and we can see here this is one of the prompts that we're using with Ollama. And on the left, we can see that we have 4 different applications: API Gateway, Document Service, Frontend, and Ollama. For each of these applications, we have a Docker file, as well as we have our infrastructure set up. So we have bicep templates all set up as with an Azure.yaml. And what this all means is that with Azure Container Apps, it's super easy to get up and running with this AI application, right? All we have to do is we can run azd up, and we'll be able to provision all of these different resources, deploy our applications, and it'll take care of all of it seamlessly for us. Now, this takes quite a bit of time to provision, so we pre-provision some resources. However, what's interesting, some of you guys might have noticed, I just mentioned 4 applications here, not 5. I showed 5 on the diagram. I promise we have 5. Basically, the latest thing that we are shipping, the latest feature, is integration with Foundry models, right? And just to give you guys an example of this, let's say we wanted to deploy a 5.4 model like for this application, right? All we need is we need to go to Model Catalog, and we can go see our model ID here. There's the registries, Azure ML, models 5.4, version 7. And we can go back and we can just run a basic AZ container app up command with the model registry set, the model name, and the model version. And what that's going to do is it's going to deploy a container app on serverless GPUs within our environment that we can then get an endpoint to interact with, generate our documents, whatever it is that we need to do. So we're actually going to go ahead and we're going to kick that off. Again, takes a little bit of time to deploy, so we've had some resources pre-provisioned, and we'll go to those now. So now, within our browser, we can see here that we have all of our 5 different applications deployed. And let's go ahead to our front end, and we're going to go open this up, hit that endpoint. While we're waiting for that, we're also going to go ahead and we're going to set up a scale test on Azure Load Test. This is just going to be used for later in the demo to show some of the scaling behavior. We're promising serverless automatic scaling. We want to showcase that. But this takes a little bit of time to run. So we're going to go ahead and hit that for our Ollama application here. So we'll go ahead, enter that endpoint. Let's not make it 20 minutes. Let's make it 2. So let's create that. And we kick that off. We'll visit this again later in the demo. Now, while we're doing that as well, we want to go into our bread and butter service. We offer a lot of tools out of the box for developing your applications seamlessly within Azure Container Apps. Some of these, we have a lot of monitoring tools as well. So we're going to go ahead and click into Logstream here. This is just real-time logs so that you can see what's happening in your application as they're happening. So we're just going to open this up just to make sure that things are processing and working the way we want them to. With that, we can go to our expense reports agent, and we can go ahead and drop in some files that we want to process. So we're going to go ahead, drag these in, and we can go ahead and upload these files. If you notice here, we have DeepSeek and Foundry as the 2 models we're selecting. So these are the models we're going to be using to process these documents. And we can see here that now in our log stream, we're starting to see things come through. So back to the front end, we can go now to our documents. And we can see all of these different files that we've uploaded. So we can see that here for the EV application, and let me scroll back out a little bit. We have pictures of receipts that we have. We also have more printed receipts. I've made some boxes. These are all receipts that I've actually used. So redacting some information there. If you find anything that I missed, please let me know. We also have our lodging receipts, hotels, and then even Gmail receipts, right? So these are all the different kinds of things that we're processing for our expense report. So let's go ahead now and let's go take a look actually at some of these reports that we're generating. So you can see here it's taking a little bit of time, but we're starting to come back with responses. So some of these are pre-generated, but past day we just uploaded right now. And you can see that we've run this now against both of these models within our environment, right? So you can see DeepSeek R1 7B as well as the Foundry AI model. So this is 5.4 that's running on this Foundry AI application. So you can see here the differences in the responses, compare them, see the amount of time that they took to generate, as well as the level of accuracy, right? So you can see here actually DeepSeek R1 7B, it actually wasn't very accurate for this response. It returned a grand total of 0, which obviously we spent around $900. So I'd like to reimburse that, right? But the 5.4 model was able to get this back pretty accurately. It took a little bit longer to run, but it had a much better response for that inferencing. But now you can imagine, right? If I had just selected up here DeepSeek R1 instead of Foundry and just left Foundry unchecked, this application would now run against just DeepSeek and no Foundry. Our DeepSeek application would scale out. It would handle the load, the requests, but our Foundry application, which is still scaled at 0, you're not paying for that, you're not using it, right? And now you can imagine you can have 5, 10, 20 different applications within this environment, all set up to basically be using these serverless GPUs, and only the ones that you're actually using will scale out when the workloads come in and to meet that demand. So that's super cool. So that's the core part of this demo. But we had this load test running as well, right? So let's just go check in on our Ollama application here. And we can just go back into monitoring tools as well. So metrics here, and let's take a look at the replica count just to make sure that we're actually seeing that load. Okay, so it's still coming through. It looks like load test is running a little bit more, so we'll revisit this, come back. These are some other tests, last minute demo building. But another thing I did want to showcase here is just the workload profiles. And I think this is something that is super special and super unique about Azure Container Apps as a Service for developing your AI applications, right? So within Azure Container Apps, we have this concept of workload profiles. Basically, these are different compute types you can have within the exact same environment. So within one environment, I can be running consumption non-GPU. I can be running serverless GPUs. If I wanted to, I could be running dedicated applications and dedicated GPUs as well, which we just went GA with. And all of these can be assigned to different applications, right? So you can see here for our app here, we only have front-end, document service, and API gateway using the consumption app, while everything else is using the serverless GPU application within that environment, right? So this makes it really seamless and easy for you to integrate your AI portions of your applications directly with your existing application workloads and build them into your application infrastructure. So with that, let's actually go back and let's just revisit this metrics page. Let's refresh this actually and see if we were able to scale out. So we'll go back in to metrics. We're going to select our replica count here. And did this actually run? It says it's running. So our metrics do take a little bit of time to propagate. So let's visit again in just a second here. But also, if you remember, we had kicked off earlier this deployment with the AZ Container App up command, specifying the registry, the model, and version. So we can also just go and check in on that right now and make sure that that is actually deployed. So we can see here, Foundry service is live. This has been deployed now. It's live. And all it took for us to do that, to get a model up and running on serverless GPUs with container apps, was that one single line command in the CLI. Okay. Okay, let's go back here. We're going to see our replica count. All right. Well, it looks like it doesn't want to behave for the demo. So you know how that is. This is actually the demo I feel the most prepared for ever, so it's kind of ironic. But you can see here the other load tests that I've basically run throughout the last 24 hours while testing this out, right? So you can see us scaling from 0 all the way to 1 and then to 10. In this case, actually, right here, we went from 1 to 10 instances. If I actually pull back the time frame, it only took about a minute or two to get from 1 A100 GPU to 10 A100 GPUs for this test. So with that, that finishes my demo portion. Let me go switch back here. And I'd like to invite Alex on stage from NVIDIA to talk a little bit more about NVIDIA NIMs, Apache Spark, serverless GPUs, and how they're leveraging all these capabilities.
Thank you, Kerry. Yes, I'm Alexander Spiridonov from NVIDIA, and mostly working with Microsoft on AI, big data, large language models. And today I will try to show you how to build very complicated applications using this Magic platform from Microsoft, of course, using Magic containers from NVIDIA. My presentation is not the first one in this line of presentations related to our collaboration with Microsoft and NVIDIA. This March, actually, ACA team already presented the first part, how to merge NVIDIA NIMs with Azure Container Applications on our GPU Technology Conference in March. And that was mostly about kind of one node application. And today I will show you how to build distributed GPU workloads, and in particular using Spark. For people not familiar with NIMs, just shortly, NVIDIA NIMs are pre-built portable Docker containers, and they easy to use, enterprise supported, and have optimized performance, and very convenient in this case, kind of to use in any application, in particular in a container service. This is kind of NIMs are covering pretty wide area of machine learning domain and models. You can see this familiar kind of text processing, visual, RAG, speech, healthcare, simulation. And on the top, you can see models we're using. That's usually it's the latest deep learning models kind of currently developed. Why Apache Spark and Service GPU? It's kind of obvious choice because for the demo I would like to build a distributed data processing, and this is kind of known area for Spark and Service GPU because of the performance, scalability, and lowering infrastructure cost. And for the demo, I choose this use case to use the GPU to accelerate distributed text embedding and data processing using ACA with Spark and SQL Server. And it's based on a typical usage of Spark and GPUs together to accelerate ETL, analytical SQL queries, and distributed machine learning with GPU acceleration. This is architecture I end up for the demo, and it's kind of impressively has only two applications. One is definitely the worker who is doing the all work, and it's GPU accelerated to have the best performance, and container application, which is organizing the work for the worker and communicating with the clients. In my case, I'm using HTTP request. Plus controller application, I will show it. It has a special mode called Jupyter, which is very convenient to develop particular applications on this Spark cluster and run it as notebooks. It's kind of a small Databricks or, I don't know, MS Fabric, something like that, very convenient separate value. And on architecture, the last piece is kind of a shared data storage, which I found very useful to persist models, code, embeddings, text, and everything. And it will be shared between worker and controller, and very convenient, again, for development and usage. This architecture is kind of defining the implementation of the demo, which is, again, has a worker part and controller. But because I'm using Spark, for controller I'm using master Spark, and it's and for the worker, they're just Spark workers on, and that's a standalone Spark installation. And you can see for workers, definitely we can use many replicas. It's a scalable ability of ACA will shine here because of the load. And for controller, it's just one replica, very simple, based on CPU, just again about controlling, and it's based, and it has a web service inside based on Python libraries. It's async IO. I think it's a Python library I'm using for web server. And at the same time, it has a Jupyter environment inside for development. Controller and worker, they connected using Azure private network. And as a shared persistent storage, I'm using file share, Azure file share. As a client, I'm using SQL Server 2025 because it has new, very convenient features to run HTTP requests against REST endpoints. And in a demo, I'm using two different approaches. They have external models to do that, and plus they have a stored procedure to communicate with the endpoint. And again, it has two modes. One is kind of development mode and trigger mode, which is production level kind of processing HTTP request. In a demo, I will I will start showing the demo with development mode with the Jupyter, and after that show you kind of production level thing. Before starting the demo, I would like to say demo is pretty fast and definitely not covering the whole functionality. It means if you're interested in some details, please check GitHub, and we'll have blogs about that. This is a QR code you can take and look what are details of the demo. And this is, and I will use Portal for the demo. This is first application, which is a worker. It has only one container. You can see it's a Spark-based container. It's currently running, and it has triggers, HTTP triggers, and it's using the volume. I was talking about the persistent storage thing. Next application is the master, which currently running, and it has, as I said, two containers. One is the Spark container. You can see it's on the top. And another container is for communication and development mode. It's scaled to 1, always 1, just kind of to the communication. And again, it has volume assigned to communicate. Yeah, because it's already running, you can see this is the standard Spark UI. You can view two workers here, and nothing is currently running. Now, if you go to Ingress or in Overview, you can click on the URL, and you will see a Jupyter notebook is open, and you will see file share available. From there, you can take the code you're developing or debugging. Spark is currently running, two workers, nothing running, and I will demonstrate how to do this small Databricks or factory with Jupyter. Let's remove the UI, some outputs from the previous runs, and you will see the code is using Spark. This is Spark session created, and JDBC to communicate with SQL Server. And I will basically update the database with embeddings. And if you this is the SQL database. I have two connections, one for the first part of the demo and another for the second. And you will see this is the table I'm populating embeddings. And currently it has 0 embeddings and all nulls for embeddings. Now, if I run this notebook, you will see in running application and a SQL in the Spark UI, you will see the application is running. With all the stuff seen now, it's run, and you will see in the notebook you have some UIs, and in the Spark UI you see two workers, and as usual you can see how it works. You see GPU is used, and CUDA for processing models. It's the simple Hugging Face model for embedding. Now, when the notebook is done, you can go back to the SQL, and instead of nulls, hopefully you will see embeddings. Yeah, this is populated in development mode. You can tune this mode, and after that, take this code and use it in production. And now let's check how the production will work. To do that, you go to a container, and in choose the container for communication. And in environment variables, instead of Jupyter, you just specify a trigger mode. And it will remove kind of Jupyter and use the parser, HTTP parser and web server. Once you kind of update this, the cluster is rebooted. Now you will see this is a brand new Spark cluster. Nothing is running, nothing is in completed applications. And now we go back to SQL. We will clean up embeddings to have them null and to do exactly the same like we did with the notebook. Yeah, I hope it will clean it. Yeah, see nulls for all text thing. And nothing is running. Now to run it, I'm using bash console and curl to communicate with Azure application, and it's running against just 1,000 rows from the database. So it's running. You can see application, the same output like GPU based, running on CUDA. It means it's doing exactly the same like notebook, but in production mode. See the query finished. And now if you go to a database and do the query, you see embeddings. It's basically the same result, but using HTTP endpoint from Azure Container Apps. And now I will show you another kind of standard SQL Server demo with a production table, which has product descriptions in different languages. This is the select query. You can see different descriptions, different languages, and after that you run embedding, and it will kind of put them on the same semantic kind of platform. And when I'm running, I'm using external models. It's a new thing in SQL Server with Alama protocol and standard methods to get embeddings. This part is just kind of introduced in SQL 2025. And another one is the batch usage of stored procedure doing the same thing. And now I run both procedures at the same time just to demonstrate they can work in parallel. Yeah, one is done, another is done too. Now, if we go back to SQL and update the query, you can see two embeddings. They currently are identical because I'm using the same model. And we added two new columns now related to embeddings. That's basically the demo, and on this note, I'm passing to my friends from Microsoft. Thank you.
Thanks, Alex. All right, so now that we've seen how Azure Container Apps jobs and apps running on serverless GPUs allows you to deploy your AI apps and agents, let's take a look at another feature of Azure Container Apps called Dynamic Sessions and how that enables you to build and deploy secure AI applications and do some pretty cool stuff with it. So Dynamic Sessions at its core is a platform for you to really easily get access to secure sandboxes for running untrusted code. This could be when you're building a multi-tenant application and you're just accepting random code from your end users that you cannot trust, but you need a place to run it. You can actually run each of that code per user or tenant in its own session so that you're protecting it from actually affecting your own application or affecting other people's code and data as well. In the context of an AI agent or an application, quite often what we want to provide our agents is the ability to run AI-generated Python code to solve problems. So we'll be going through a couple of demos today to kind of show you how we can use sessions to do some pretty interesting things. But before we get into that, I just want to kind of quickly go through the different requirements for actually running, in this case, AI-generated untrusted code at scale. So the first is we all care about security. And dynamic sessions, each session is actually wrapped in a Hyper-V sandbox. So you have probably the highest security that's available to us to execute the code and kind of protect yourself from having that code affect anything else negatively. And dynamic sessions is really high performance. We actually run a pool of sessions ready to go. And a session could be a code interpreter, it could be anything else that can run any untrusted code. And so when you send some code to a dynamic session, within milliseconds, that code, we will actually allocate you one of the sessions and then execute the code. And quite often when you're kind of managing tens, hundreds, maybe thousands of these sandboxes, you don't really want to explicitly create and delete them. So we actually make it really easy to manage the life cycles of these sessions. So when you send code to a session and you give it a session identifier and we don't recognize that identifier, like that we don't have a session for it, we automatically allocate you that a session for that identifier. And then any subsequent calls into that session, we will just route to that session. And then if you don't use your session for a while for that given identifier, we automatically clean it up for you. And you can actually control how long we wait before we do that. So you don't really have to worry about creating or disposing of these things. And the last kind of concern for running these things at scale is, of course, scalability. And within Microsoft, actually quite a few different products are using dynamic sessions whenever they need to execute code, especially LLM-generated code. OK, so that's the slide. Let me see if I can cut over here. 2? Nope, 3? That's me. OK. So we're going to do 2 demos. So the first one is, I think there's a requirement that every session has to do MCP. So here we are. So we are going to show you how we can use MCP to provide Dynamic Sessions code interpreter as a tool to a MCP client. So for those who don't know, MCP is probably the new universal way of creating a tool that you can provide to an agent. So you don't have to kind of write a tool for LangChain, write a tool for Llama Index, write a tool for semantic kernel. You just write this once, and now you can provide an MCP server to really any AI agent going forward. And they'll be able to use the tool. So in this case, we're going to write one that will run some code in dynamic sessions. So let's see if this is going to work. OK, so before we get there, we are going to just quickly look at the Azure portal to see how you can get access to dynamic sessions. So the first thing that you need to do is go to the Azure portal, or the CLI, or Bicep, and create yourself a session pool. So it takes about 10 seconds to create. And in this case, I am creating a Python code interpreter session. So you actually don't even have to know containers to use this because the code interpreter scenario is so common that we actually provide you a way to create a pool with a Python code interpreter out of the box. So now that you've created it, we actually give you an easy way to actually play around with sessions as well. So we're going to give you this little UI. And like I was saying before, each session can have an identifier. So I'll just call this build. And then I'll go ahead and run some code in it. So you can see within less than a second, I've allocated a session and actually ran this code there. And I can run additional code in this session. I can just set a variable, run that, and then there's no output here. So, and then I can say maybe a times 6, run that. You can see that the result's 42 because I'm actually running this code in the same session. But it's actually super easy to switch to another session. If I just put the number 1 here at the end, change the identifier, and I run this code, what I end up with is a new session. And I know that because the value or the variable a doesn't exist here. Right? So behind the scenes, it's just calling a bunch of really simple APIs to execute code. So we can do this in our applications as well. So let me do that. All right, so here I've chosen one of my favorite languages, JavaScript, to write an MCP server. So in this case, it's actually pretty straightforward. If you go to the MCP website, there's examples to do it with any language. So in this case, I chose JavaScript and Node. And I just want to quickly call a few things. So all an MCP server is, if you haven't built one yourself, is it's just a process. In this case, it's going to spin up locally that the MCP client is going to connect to. And it's going to talk to it over standard I/O. And then we can actually expose one or more tools to the client by, in this case, just by running the server.tool method. So in this case, I am exposing one tool called run code. And then I'm actually giving it some instructions describing the tool. It's a Python code interpreter. I was actually having trouble in some cases forcing it to use this tool. So I'm actually telling it, hey, always use this tool whenever you need to perform any calculations or anything to do with math, yada, yada, yada. Trying to convince the agent to use my tool. It's almost like I'm trying to sell it something. And then I'm telling it that it's going to come back with the result, standard output, and all that stuff. And then the code of this MCP server is actually pretty simple. I take in the Python code that the agent wants to run, and then I am just making a post to my session pool endpoint and calling the executions endpoint because I want to execute some code. And then I pass the code in here. And then the other key part here is I'm passing a session identifier. So in this case, I'm just being lazy. The whole MCP server is only going to use one session ID. But you can kind of picture, you can actually do different things depending on, if you want to have different sessions per conversation, if you can actually figure out what conversation each request is coming from, or each tool call is coming from, you can actually, change the identifier on the fly and have them run in different sessions. But that's it, and then it comes back with the result, standard out, and standard error. I just make it a string, and I just hand it back to the MCP client, and that's really the extent of my application here. So, and the other thing I did was, I think maybe you've all kind of seen MCP working in VS Code. So here I'm actually going to show you how to do this in Claude Desktop. So you kind of configure it the same way as you would in VS Code, just slightly different syntax. But here I'm kind of saying to run this MCP. I'm basically configuring one or more MCP servers, in this case a code interpreter MCP server. And I'm telling it that, hey, just use Node to run this particular entry point and pass my session pools in as an environment variable. And then it's going to work. So, and then it's going to spin it up whenever I open up Claude Desktop. So I'm going to go ahead and open Claude. Hi, Anthony, how are you? So friendly and polite. Yeah, but we can see that it's actually working by opening here. So you can actually see that it actually started the MCP server process behind the scenes. It actually already talked to it, interrogated it, and actually found out it has exactly one tool, which is run code. And I can turn this on and off if depending on whether I want it to be participating in this chat. In this case, I do. I can kind of ask the questions like, what is some giant random number times some giant random number? And then I hope what it's going to do is it's actually going to write some Python code to do that calculation. In this case, it's pretty straightforward. It's just going to multiply the two things together. And in the interest of security, Claude actually asked me if I want to run this or not. I'm going to allow it. It's going to go and run it. And it'll come back with, hopefully, come on, or not, a result. Oh, there we go. Yes, no, yeah. We can see that the session execution actually came back with the result. And then basically, Claude just echoed that back to the screen. As you can probably imagine, kids can now use this to cheat on their homework, which is what we're going to do next. I found this math problems thing here, and we're just going to maybe randomly choose one math problem, take this, and paste it into Claude. and hopefully see it do something a little bit more interesting. So here, it's written some code, or it's writing some code right now. So you can see that it's writing some code to calculate, I don't know, I don't even know what the question's asking. It doesn't matter. I'm just going to say allow run, allow once. And then it came back with a result. Don't know if this is right, but let's see. We're going to take this and check the answer. Is it this one? Which question did I ask? This one. Check the answer, and we got it right. This is bonkers. OK. So that's one way that you can use dynamic sessions if you want to cheat on your grade 8 math homework. So another thing that I want to kind of show you is the second demo. Let me just quickly cut back to my slides to show you that. There's a new type of agent, a newish type of agent. It's like 3 or 4 months old, but that's old, I guess, by AI standards. But there's a new type of agent called computer using agents that it's actually able to almost like drive a UI in order to solve a problem. So what we do is we start with a computer, quote unquote computer, which can be just a browser, or it can be an entire OS. It's really anything you can take a screenshot of. And then what we do is we take a screenshot of that thing, and then we take some input from the user. Say, I want to find the value of like Microsoft stock or something like that. And then I basically pass those two things into the computer using agent. And the agent will, quote unquote, decide what it wants to do next. So it might be that I want to click in the search box. And then after it's clicked on the search box, we take another screenshot. We give it back to the agent. And the agent might say, hey, I want to type the words Microsoft stock. And then we kind of go through this loop. It's going to kind of next click the search button maybe, and then maybe it's going to click on a website that it comes back on, and until eventually it figures out the answer. So that's kind of how a computer using agent works. I'm going to quickly show you how to do this locally on your machine, and then we're going to see how it runs in sessions. So not this one, it's this one. All right, so I already have this sort of set up. So in this case, it's a Python application. And here I'm starting the local Playwright version. So what we should see happen is that we're going to spin up a Chromium browser. And then when it spins up, we can ask it a question. Unless it doesn't spin up. OK, it does. OK. And then we can ask it a quick question. What's the weather in Seattle? And then we can actually see back here, it's actually kind of deciding that it wants to click on something. And then if I kind of flip back, hopefully we can kind of see both. So basically, we're actually, the Python app is actually driving the browser using Playwright. So every time the agent says, I want to click something or type something, it's actually doing this in the browser. And then hopefully, it'll come back with the right thing. So you can see it already has enough information. Sometimes it decides to click on stuff to keep going. Hopefully it doesn't do that. Hopefully it just stops now and says, I know the answer. Nope, there you go. So it did stop. So it says the weather in Seattle, Washington is currently sunny, temperature of 59 degrees Fahrenheit. I don't know what that means. I'm Canadian. So that's kind of how computer using agents work. So I'm just going to quickly show you how easy it is to actually take this browser and run it in a container apps dynamic session, because quite often you want to do this because you want to do this in a multi-tenant way. So you actually want to have an API where someone can ask a question, and then to answer the question, it's actually running a browser behind the scenes. So I'll just quickly stop that. I will switch to here. I'll super quickly kind of show you what you have to do. So you just have to implement what's called a computer. In a computer, all you have to do is implement a few things, like what to do when the agent wants to take a screenshot. You basically take a screenshot. In this case, I'm calling into the dynamic session to take a screenshot, and then basically returning that as data. You can click, it can type, double click, stuff like that, right? You can kind of imagine what you need to do. And I'm just basically writing that like basically writing a dynamic version of it so that it will execute that stuff in the session itself. So what am I doing? Oh, I got to go back to my window here. And instead of using the local playwright, I'm going to go use the other computer, the sessions computer. The main difference that you'll notice is that there's no browser opening up because the browser is now running in a session. So I've already allocated the session, and I am basically initializing the browser. So basically running some playwright commands to load up the browser and stuff like that. I'll just kind of quickly do this. What's the weather in Seattle? You can probably do some more interesting stuff. And we can see actually it's going to go and do its thing. But Sessions, the Python code interpreter, actually includes everything you need to run Playwright and Chromium. And that's why this is possible today. And because this is running remotely, what I have done is that I have this agent basically outputting or saving logs locally. And then I can go ahead and copy this. Or so I copy the path and just quickly open this in my web browser. And we can see kind of what it's doing remotely. I'll quickly kind of show you some more interesting scenarios. In this case, I'm like, hey, what are some family-friendly events that are happening in Seattle this weekend? And actually went and searched the web and found a website and kind of scrolled through the website until it kind of found me basically all the events that are happening this weekend. Here is, what are the container apps announcements? Again, it found all the announcements. And this one here, I'm like, I love container apps. Recommend me some sessions at Build, and they went to the Build website and searched for container apps. And then again, it came back with some sessions to check out. Well, actually, it came back with some sessions to check out, and then it asked me whether I wanted more information. And then I asked it to show me more about the lab, and then it actually came back and told me more about the lab by clicking around some more. And then lastly, I asked it to book to try to book a flight, and then it asked me what airline to use. I said Alaska or something like that, and it actually went to the Alaska website. It knew how to use the date picker, figure out how to choose the right dates and all that, and then eventually told me all the flights. Right? So it's pretty cool what it can do. And yeah, and all this is powered through a computer using agent. I'll kind of quickly just show you how you can get access to the model. And within the model catalog, you can search for computer using agent, or sorry, computer use preview, and then you can grab access to that model. But I think that's all the time I have for this demo. So I want to just hand it off to Viom to close this out. Thanks, everyone.
Thank you, Anthony. Okay, so you already went through some of this. So then let's just quickly wrap up. So we heard quite a lot today about serverless GPUs, of how you can use serverless GPUs in apps and in jobs. And then Anthony also walked through a lot of the things which you can do in dynamic sessions. Now, all of these were the serverless computing options. As Carrie called out, we also have dedicated GPUs available. So these are 4 things which you want to do more in production. There are things which you need the capacity to always be available because either you're running it 24/7 or you just need that guaranteed capacity, guaranteed performance. So that's another offering which we have, which also goes GA at Build. So that's another one you can try out. But now, again, combining those 2 offerings together, what Anthony talked in terms of dynamic sessions and how quickly they can scale up, we are pleased to announce that we want to bring serverless GPUs to dynamic sessions in private preview. So now this is then ideal for the type of workloads which need an isolated environment, which need that super fast responsivity. But then also, you want to do things which would require something like a GPU, like whether it's just regular data processing or it's more ML or AI heavy workload type of things. So this now is the fastest way to access a GPU in the industry. You go and call an API that gives me a dynamic session with a GPU. In milliseconds, you have a GPU available where you can start doing that work. It's also the industry first isolated sandbox which can run GPUs. So now this allows you to build those multi-tenant applications at serverless scale where you can have GPU for each of the individual workers which are getting kicked off. And you can also go from running these small snippets of code, which kind of Anthony showed, where you're trying to just do things, but also when you're trying to do heavier things, it's not just a browser which you're running, but it is actual some real data processing workloads which you're trying to pull in on behalf of each user request which coming in. And the user could be multiple different users, but you could still use the same session pool because each of these is isolated from the sandbox. I also want to do a quick call out that these dynamic sessions GPUs, which we called out, is also available through Microsoft DevBox today. So this gives a very easy way in which you can use these serverless GPUs using dynamic sessions through the Microsoft DevBox, the way you would kind of open like a local shell inside of Microsoft DevBox today. You'll see that there's a remote shell available, which is called like the GPU resource with DevBox, which will give you a remote shell. But in the future, you'll see that because that is tying back to the same persistent space, the persistent disk which the DevBox is connected to, you can effectively use it as if it's a local thing. So with that, just as a quick recap, we talked about 3 different things today. We talked about how we can do serverless GPUs for the inferencing scenario, which Gary walked through. We talked about how you can then take the same serverless GPUs and run more of those multi-GPU, multi-node scenarios, which kind of Alex covered. And then we also talked about how you can have the secure AI-generated code using dynamic sessions and how you can have GPUs accessible to those. So with that, we have a lot of content out there. Please do look it up. Immediately after this, we have a session right next in the next room where we're going to talk more about how you can use and build real AI applications with Azure Container Apps. So hope you folks have a great build.